morning, classmates. My name is Lennon. We are here at Zuma State Beach, and I will be talking about soft stabilization.
My name is Consuelo Rodriguez, and I'll be talking about wave cut platforms.
My name is Ashley Gonzalez, and I will be talking about wave cutting.
My name is Sydney, and I will be talking about hard stabilization. Here at Zuma Beach, you will find that there isn't hard stabilization compared to other beaches such as Santa Monica. Hard stabilization is the use of man-made protective structures to control erosion. There are different types: groins, seawalls, revetments, rock armor, gabions, and breakwater. Groins are wooden, concrete, and or rock barriers or wall perpendicular to the sea. Here is an example of groins. They would be these. Then there is seawalls, usually of masonry, concrete, or rock, built at the base of a cliff. And they act as a layer between coastline and oceans, as they help insulate communities from flooding. Here you will find a picture of an example of seawalls. Then we have revetments. They are a type of structure that is built along an embankment, shoreline, or steep facing slope in order to protect it against erosion generated by waves or current action. They're like seawalls, but instead of standing vertically, it coasts into the shoreline to protect. So here is an example of what would it look like. It would go deep down that way. Then we have rock armor. Rock armors are large rocks piled or placed at the foot of dunes or placed at cliffs, which are placed with native stones on the beach. They're also known as riprap, rubble, or shot rack. That would be this. Then we have gabions. They're boulders and rocks that are wired into mesh cages and usually placed in front of areas to heavy to moderate erosion. They provide stability to cliff areas. So this would be gabions. Then we have breakwater. They're structures constructed on coast as part of coastal defense or to protect an anchorage from effects of water and longshore drift. Here is an example. So it would be that on the side. The pros to having this is they interrupt the forces of waves impeding the flow of sand down the beach, which allows tourists or anybody to have more contact with the beach. It does prevent the waves from crashing into some structures that are already built near the water. Some cons would be that they destroy recreational beach, deflecting erosion to the sand. It threatens habitats and nesting grounds, and it's very costly to initially build and continually maintain. As you can see here at Zuma Beach, the only thing we have towards that is these rocks behind me. Thank you, that's it.
Hello guys, my name is Lennon, and I'm going to be talking about soft stabilization. So, what is soft stabilization? Soft stabilization is the process of bringing sand to beaches. So, beaches go through the process of erosion, and waves cause this erosion. As you can see on my left side, waves are constantly hitting and coming, taking all this sand. I don't know if you can come in closer. There's some huge slopes. To my left, you can see there's a slope. There's a slope going down. This is a proof that there is beach erosion. Okay, anyways, so soft sand stabilization is the process of bringing sand to the beaches. Here is an example. This type of sand is not normal sand. It's actually a darker color. Normal sand beaches would have a lighter color, but since they bring it from the mountains, it's darker. How do we get this sand? Residents around the area have the ability, actually the resources, to purchase or pay companies in order for them to get more sand to their beaches. So, as the sand is eroded away, there's really less beach. This means that people can't walk, tourists don't come anymore because there's nowhere to go. And in order to bring more tourists and individuals to the beach, there has to be more space for people to fit. So that's why they do this type of soft stabilization. Furthermore, soft stabilization is eco-friendly. It doesn't disrupt the environment of fishes and creatures marine life that live around or near the coast. And on the other hand, hard stabilization, as mentioned previously, they have to build man-made walls, and this causes disruption. It causes sea life to die out because there's not water coming in. Furthermore, it's very inefficient because they will let you erode away again. Self-stabilization is a way to keep beaches fully developed, but and on the other hand, it does kind of affect the money-wise. On the East Coast, beaches are long. You can see miles and miles of sand. There's no slope because Atlantic plate is different. I guess the waves don't come hard enough in order to take the sand away. But on the Pacific coast, the sea is very harsh, so that's why we get this type of erosion. Thank you.
Hello class, I will be talking about wave cutting. Wave cutting is an indentation cut into the sand cliffs at water level by the waves. The waves and currents leave behind a bedrock surface of a water table. As you can see here, that's an example of it. If you come this way, you can see the markings left behind by the waves. The cutting leaves an indentation of markings of where the waves stop. It is darker than the rest of the beach because it is taken into the ocean slowly. So there are two different types of slopes involved in wave cutting. One is the slanted slope, which is almost horizontal, so it's not as harsh as the harsh slope, which is the second one. A harsh slope is very steep, in measurements almost 45 degrees in greater. As you can see here on this cliff, there are markings left behind on the cliff demonstrating that at one point there was wave cutting that occurred on this cliff. As time goes by, the waves take in sand, and that's the reason why we need stabilization, hard or soft, to make sure that we don't lose the connection to the beach. So this here is the natural beach, and if you look up towards the parking lot, that is artificial sand that was added for stabilization. If you take a close look at the wave, you can see the brown color in the waves, and that is actually sand that was brought into the ocean. Wave cutting is a form of erosion, and many people think that erosions are hazards, but it's actually a natural process that helps beaches recycle sand.
Wave cut platforms occur all the time at the beach, and it has various effects. It is very clear it is affecting the beach and residents living nearby. However, these residents are worrying and even sometimes stressing out about cliffs and earthquakes. Basically, a wave cut platform is located at a place where there's a cliff next to the water. The water and sand are being moved back and forth. For example, when waves erode, it causes them to fall in a sea level. When being eroded, the rock starts to feel very, very weak, and it tends to crack. In other words, residents that live near the beach can be very dangerous during an earthquake because it causes pieces to break and fall down. And a few times like this, it causes cliffs and larger rocks in slow motion to lose pieces from the very top. And these pieces eventually become very small. As a result, this makes everything fall apart and rocks are hitting each other or everywhere. When this occurs, there's no way to stop the cliffs and rocks to stop because there's no fully support and the force is very strong. In other words, these pieces are becoming homes to sea life species. The wave cut platform is being formed after the destructive waves that hit against it. A destructive wave creates when there's a strong storm and the waves are very powerful. Wave cut platform is another agent of deposition and erosion of sediments. As you can see, these rocks are examples of erosion. As you can see, these waves keep forming on the rocks due to the impact.